Good day, everyone. Today's topic is cross-validation from evaluation of learning algorithm. So, what is cross-validation? Cross-validation is a statistical resampling techniques used to evaluate the performance of a machine learning model by ensuring it generalizes well to unseen data. It works by partitioning a data set into multiple subsets, training the model on some and validating it on others, and then averaging the results to reduce overfitting. Uh, Core cross-validation techniques, cross-validation methods are generally categorized into non-exhaustive and exhaustive types. Non-exhaustive methods, these methods do not compute all possible ways of splitting the original data, making them more computationally efficient for large data sets. Holdout method, the simplest form where the data set is split once into a training set and a testing set, typically 70 is to 30 or 80 is to 20. While fast, it can be highly sensitive to how the data is split. K-fold cross-validation, the most common techniques, the dataset is divided into equal folds, and the model is trained times each time using a different fold as the test set, and in the remaining. And the remaining folds for training. The final performance is the average of all iterations. Stratified K-fold. What is stratified K-fold? The variation of K-fold design for imbalanced datasets. It ensures that each fold contains approximately the same portion, a proportion of target classes as the full dataset. A repeated K-fold repeats the K-fold process multiple times with different random partitions in each repetition to further reduce variance. And exhaustive methods, these methods test all possible ways to divide the original sample, providing a comprehensive evaluation at a high computational cost. Leave one out cross validation, so LOOCV, a special case of k-fold where equals the total number of data points. Every single data point acts as a test set exactly once while the model trains on the other points. It is highly unbiased but extremely slow for large data sets. Leave P out cross validation, LPOCV, leaves out observations as the test set and uses the remaining for training. This process is repeated for all possible combinations of samples. Specialized techniques, certain data types require specific cross-validation strategies to maintain data integrity. Time series cross-validation, standard shuffling is avoided because temporal order matters. It often uses a rolling or forward chaining approach where the training set grows over time and only feature observations are used for testing. Group K-fold used when data contains groups of dependent samples, example multiple medical readings from the same patient. It ensures that all samples from a specific group are either entirely in the training set or entirely in the test set to avoid data leakage. Nested cross validations involves an inner loop of hyperparameter tuning and an outer loop of estimating generalization error. This prevents the model evaluation from being biased by tuning process. Comparison summary, like a holdout large data sets, best used for, and primary advantages computationally fast, primary disadvantage high variance in results, k-fold general purpose, balanced bias or variance, computationally expensive, stratified imbalanced data maintains class ratios, same cost as for k-fold, LOOCV, very small data, minimal bias, extremely slow, high variance, time series chronological data, respects time order, complex to set up. And cross validation in machine learning, like cross validation is we see in depth. So cross validation in a technique used to check how well a machine learning model performs on unseen data by preventing overfitting. It works by splitting the data into several parts, training the model on small parts, and testing it on the remaining part, repeating the resampling process multiple times by choosing different parts of the data set, averaging the results from each validation step to get the final performance. Types of cross validations are like holdout validation. In holdout validation, the data set is split into training and the testing sets. Common splits include 70 to 30, 80 to 20, or 75 to 25, depending on the data set size and problem, making it simple and quick to apply. LOOCE. is leave one out cross validation. In this method, the model is trained on the entire dataset except for one dataset point, which is used for testing. This process is repeated for each data point in the dataset. All data points are used for training, resulting in low bias. Testing on a single data point can cause high variance, especially if the point is an outlier. It can be very time consuming for large datasets as it requires one iteration per data point. Stratified cross validation, it is a technique that ensures each fold of the cross validation process has the same class distribution as the full dataset. This is useful for imbalanced datasets where some classes are underrepresented. The dataset is divided into k folds, keeping class proportions consistent in each fold. In each iteration, one fold is used for the testing and the remaining folds for training. This process is repeated k times so that each fold is used once as the test set. It helps classification models generalize better by maintaining balanced class representation. K-fold cross-validation. K-fold cross-validation splits the dataset into k equal size folds. The model is trained on k1 folds and tested on the remaining fold. This process is repeated k times, each time using a different fold for testing. Note, a commonly used the value of k is 10, but the choice depends on the dataset size and problem requirement. Example of k-fold cross-validation. The diagram below shows an example of the training subset and evaluation subsets generated in k-fold cross-validation. Here we have total 25 instances, dataset training test. So this is how it will happen. And k-fold cross-validation. So here in this picture you can see that test is performed on different types of data sets. So accordingly, the training data set will vary in the given data set. The k-fold cross-validation, here we will take k as 5. First iteration, the first 20% of the data 1 to 5 is used to for testing, and the remaining 80% 6 to 25 is used for training. Second iteration, the second 20% 6 to 10 is used for testing, and the remaining data 1 to 5 and 11 to 25 is used for training. This process continues until each fold has been used once as the test set. Iteration training set observations, testing set observations. Each iteration uses different subsets for testing and training, ensuring that all data points are used for both training and testing. Comparison between K4 cross-validation and holdout method. K4 cross-validation and holdout method are used techniques, and sometimes they are confusing. So here is the quick comparison between them. Features K-fold cross-validation and holdout method. Data split. Data set is divided into K-fold and each fold is used once as test set. Data set is split once, typically into training and testing sets. Training and testing. Model is trained and tested K times, each fold serving as test set once. Model is trained once on training set and tested once on test set. Bias and variance. Lower bias, more reliable performance estimates, and variance depends on K. Higher bias if the split is not representative and results can vary significantly. Execution time slower, especially for large datasets because model is trained K times. Faster only one training and testing cycle. Best use case a small to medium dataset where accuracy estimation is important. Very large datasets are when quick evaluation is needed. So this is a program, and we'll see the implementation. And main advantages and disadvantages of the cross-validation or better performance estimates provides a more reliable correlation than single train test split. Redis overfitting helps ensures the model utilization will to unseen data set. Efficient use of data, all data points are used for both training and testing at different iterations, flexible force with different types of data sets and models. Disadvantage is computationally expensive. It can be computationally expensive, especially when the number of folds is large. Time consuming methods like LOOCV can take a long time for some for data sets with many data instances. Bias variance trade-off. Few folds may result in high bias, while too many folds may result in high variance. Thank you.